In this video, we're gonna study ultimatum game with the FS model. So we know that in ultimatum game, there are two individuals. So in ultimatum game, we have two individuals, proposer and responder. So we have two individuals in ultimatum game, proposer and responder. So proposer has a resource in the beginning, and proposer is going to propose the share. So S is a number between 0 and 1. So proposer is going to propose a share of the resource to responder. And then responder has to choose whether to accept or reject. If responder rejects, then both proposer and responder obtain nothing. So their payoff is 0 and 0. So this first number represents proposer's payoff, and the second number represents responder's payoff. If responder accepts, then proposer gets 1 minus S share of the endowment, and responder is going to obtain S share of the endowment. So for example, if S is equal to 0.4, it means that proposer proposes 40% of the resource to responder. So if responder accepts this offer, then responder is going to get 40% of the resource, and the remaining 60% goes to proposer. So this is ultimatum game. So if we think about responder's choice, responder, so according to traditional theory, we know that responder is going to compare his own payoff. So in traditional theory, the individuals only care about their own payoff. They don't care about others. So when responder has to choose whether to accept or reject the offer, responder is going to compare his payoff when he accepts the offer and his payoff when he rejects the offer. So basically, responder is going to compare S and 0. So traditional theory says that as long as S is some positive number, responder is going to accept the offer. So anticipating this, in the beginning, proposer knows that as long as S is a positive number, responder is going to accept the offer. So proposer is going to propose the smallest possible offer. So we can say that S is going to be some number very close to 0. So saying that some number very close to 0 is not convenient. So we're gonna just say proposer is going to offer nothing. So proposer is going to offer almost nothing to responder, and responder is going to accept the offer. So in the end of the story, traditional theory predicts that proposer is going to get everything for himself, and responder is going to get almost nothing. So this is the prediction from traditional theory. But we know that in experiment on ultimatum game, this is not true, because in experiment we find that typically proposer proposes a certain proportion of resource to responder, and sometimes responder rejects some positive offer. So we want to explain this kind of experimental findings. So here in this video, we're gonna try to understand what's going on by using FS model. Suppose S is bigger than half. So it means that proposer offers more than half of the resource to responder. So first, let's suppose proposer offered quite good offer to responder. So in this case, proposer offered more than half of the resource to responder. In this case, let's think about responder's choice. So responder can either accept or reject this offer. If responder rejects, then utility of responder is 0. Why? Because first, responder gets nothing. And second, there is no inequality here because if responder rejects the offer, then both proposer and responder get nothing. So there is no inequality here. So there is no disutility from inequality. Therefore, responder's utility is equal to 0 if responder rejects the offer. Now, what if responder accepts the offer? Utility of responder is first, his own consumption, S. And because S is bigger than half, responder is going to feel compassion. So we're going to have a beta term here. So beta of responder. So we don't have alpha term here because responder, as long as S is bigger than half, responder is gonna get more than proposer. So responder is gonna feel compassion. So we have beta term here. And the extent of inequality is the difference between what responder has and what proposer has. So we know that this utility is bigger than 0. So how do we know that? So this utility is beta is a positive number, and 1 minus s is also a positive number. So we know that if we subtract this number, then our expression gets smaller. And this is equal to 1 minus beta times s. Then we know that s is bigger than half. And we also assume beta is less than 1. So this is a positive number. Therefore, this blue utility from accept is bigger than 0. So utility from reject. So responder is going to accept the offer. So this basically means if proposer offers more than half to responder, then responder is going to always accept the offer, never reject. So this sounds very intuitive. And now let's think about the other possibility. So now let's think about the other possibility. So suppose S is less than half. So in this case, proposer offered less than half of the resource to responder. Then what's gonna happen? So let's think about responder's choice. So responder has to choose either accept the offer or reject the offer. If responder rejects the offer, then utility of responder is equal to 0. Why? Again, if responder rejects, then responder's consumption is equal to 0. And there is no inequality in this case because if responder rejects the offer, then both proposer and responder get nothing. So if responder rejects the offer, responder's utility is equal to 0. What if responder accepts the offer? In this case, responder's utility is equal to first, his own consumption. Second, we can see that there is inequality here. In particular, responder's share S is less than half. So if responder accepts the offer, responder is gonna get less than proposer. So responder is gonna feel envy. So we're gonna have alpha. So alpha parameter here is alpha parameter of responder. So we have to say alpha R, but let me just ignore this point here. So just know that this alpha parameter here is alpha parameter of responder. And in general, alpha parameter may be different between responder and proposer. So let's ignore this point here for the sake of simplicity. So we have alpha comes here. And the extent of inequality here is the difference between what proposer has and what responder has. So in this case, proposer has 1 minus S and responder has S. So the extent of inequality is this much, and responder is gonna feel envy about this inequality. Okay, then so this utility, so utility from accept. So we want to compare utility from accept and utility from reject. So we can see that if this blue expression is bigger than 0, then responder is going to accept the offer. Otherwise, responder is going to reject. So in other words, if blue expression is a negative number, then responder is going to reject. So is it possible that this blue expression is negative? So blue expression here is negative. So this is possible if alpha is really big. So in other words, when responder accepts the offer, responder is gonna get less than half of the resource. So in this case, responder is going to consume and get some positive utility from consumption. But if alpha is really big, responder is gonna feel a big amount of this utility from inequality. So because of this effect, it is possible that responder's utility is negative. If this is the case, then responder is going to reject the offer. Therefore, responder is going to reject the offer if this blue expression blue expression is less than 0 and accept otherwise. So this inequality, so we can rearrange this inequality to get this blue inequality at the bottom. And let's define this fraction. So let's define this fraction as a number s upper bar. And as we can see, this fraction depends on alpha parameter. So this number s upper bar is a function of alpha. And we can see that this number is less than half. So how do I know? Let's begin with this inequality. So we know that number 1 is bigger than number 0. Add 2 times alpha to both sides. So we get 2 alpha less than 1 plus 2 alpha. Divide by number 2 on both sides. So 2 disappears here. And divide both sides by 1 plus 2 alpha. So 1 plus 2 alpha disappears here. So we can see that this inequality is true. So alpha over 1 plus 2 alpha is less than half. So this means this blue inequality is here. So this means here is number half. And here is some number called S upper bar. And this is a function of alpha. This inequality means if S is in this blue range, then responder is going to reject the offer. Otherwise, S is in this green range. So remember, we are thinking about the case where S is less than half. So S is less than half, but bigger than this threshold S upper bar. In this case, responder is going to accept the offer. So here reject, and in this green range accept. And this finding is very intuitive. So it basically says responder is going to reject the offer if the offer S is less than some threshold. So in other words, responder is going to reject the offer if offer is too small. But otherwise, responder is going to accept. So this finding is quite intuitive, and as we can see here, we can explain why responders in our ultimatum game experiment often reject some positive offer. So as we saw before, traditional theory cannot explain why responder rejects some positive amount of offer, but as we can see here, if we use FS model, we can explain why responder may reject some positive amount of offer. So it's because of basically responder may feel great inequality if we accept. So because of this inequality, responder is gonna feel envy, and this is gonna lower responder's utility, and it is possible that utility becomes negative. So responder, in this case, responder is gonna reject the offer, and it's better to get utility 0. Okay. So let's combine our finding. So here we thought about S less than half case, and before this case we thought about S bigger than half. And we know that if S is bigger than half, then responder is going to accept the offer always. So we can say if S is bigger than half, responder is going to accept. So we can complete this picture here. So this is so-called responder's strategy. So responder strategy or responder's action. So responder is going to reject a small offer. In particular, responder is going to reject if offer is less than this threshold S upper bar. But otherwise, as long as offer S is bigger than this S upper bar threshold, responder is going to accept. Then, anticipating responder strategy, now proposer is going to make an offer to maximize his utility. So now let's think about what is best offer for proposer. So let's think about proposer's offer choice. So what does proposer want to do here? So what's gonna happen if proposer gives more than half? So if proposer gives more than half, what's gonna happen? So in this case, so if proposer gives more than half, utility of proposer is equal to, so S is bigger than half, so proposer offers more than half of the endowment to responder. So proposer's consumption in this case is 1 minus S. And there is inequality here. So we're gonna subtract this utility. In particular here, because proposer offers more than half to responder, proposer has less than responder, so proposer is gonna feel envy. So we have alpha term here, and extent of inequality here is the difference between what responder has and what proposer has. So this is equal to this is utility of proposer if proposer offers more than half of the resource to responder. What if proposer offers exactly half? If proposer offers exactly half, then proposer's utility is first his own consumption. So proposer offers S to responder, and proposer's share is 1 minus S, and 1 minus S is equal to half in this case. So first, proposer's consumption half, and in this case, there is no inequality because both proposer and responder obtain exactly half, the same amount. So there is no inequality, so there is no disutility from inequality here. So proposer's utility is equal to half. And we can see that this blue expression is less than half. So how do we know? So this term over here is positive number because S is bigger than half. So this term is positive number. So this is a negative number. So we can see that this blue expression over here is less than 1 minus S. So this blue expression over here, proposer's utility when proposer offers more than half. So this blue expression over here is less than 1 minus S because we know that this is a minus number. So this is a negative number. So we know that 1 minus S is bigger. And we know that 1 minus S is less than half because S is bigger than half in this case. Therefore, we know that proposer's utility when proposer offers more than half is less than proposer's utility when proposer offers exactly half. So this means proposer is going to never offer more than half of the resource to responder. So this seems quite intuitive. So using FS model, we can see that first, proposer is gonna never offer more than half of the resource to responder. Maybe proposer offers exactly half, but never more than that. So our first conclusion here is proposer's offer is going to be always less than or equal to half of the resource. So this means proposer is going to always feel compassion because a proposer offers less to responder. So we're gonna have beta term in proposer's utility. So proposer's utility is, so let's think about proposer's utility. So we know that proposer is going to offer less than or equal to half. So at best, proposer is going to offer exactly half, but proposer is going to never offer more than half. So proposer's utility is going to be, so his consumption, so 1 minus s, and there is inequality. So in particular, proposer is gonna get more than responder. So proposer is gonna feel compassion. So we have beta term, and the extent of inequality is proposer's share minus responder's share. So this is equal to, so this is equal to so let's rearrange this expression in terms of s. So we can rearrange this expression. So we can rearrange this expression in this way. So proposer is gonna choose S to maximize his utility. So what is the best choice for proposer? Now this coefficient matters because suppose beta is bigger than half. So if beta is bigger than half, then this coefficient here is a positive number. So if we draw proposer's utility as a function of s, we can see that this is a straight line. This is a straight line with a positive slope. Therefore, in this case, to maximize his utility, proposer is going to offer the maximum biggest possible number of s to responder. So in this case, proposer is going to offer exactly half. So what does it mean? If beta is bigger than half, it means that proposer is the type of person who feels great compassion. So in this case, if there is a even small degree of inequality, proposer is gonna feel a lot of compassion, and he's gonna lose a lot of utility because of this type of inequality, and he doesn't like it. So proposer is gonna offer highest possible share to responder to minimize inequality here. So proposer is gonna offer exactly half to responder. If beta is less than half, then this coefficient over here, so this coefficient over here is negative. So if we draw proposer's utility as a function of s, you can see that this utility function is a straight line with a negative slope. So in this case, to maximize his utility, proposer is gonna try to give lowest possible share s to responder. then what is the answer here? So the answer is not zero, because we know that from responder strategy, we know that if proposer offers too little, then responder is going to reject the offer. And if responder rejects the offer, proposer and responder both get nothing, and it's also bad news for proposer. So in this case, proposer is gonna try to give lowest possible share to responder, as long as responder is going to accept the offer. So that means proposer is going to propose exactly this value of share. Because otherwise, if proposer lowers offer, then responder is gonna reject right away. So the lowest possible value of share that proposer can offer to responder is S upper bar. Therefore, if beta is less than half, so in this case beta is relatively small, therefore in this case we can see that proposer is the type of person who doesn't really care about inequality. So he doesn't feel great degree of compassion toward others. So in this case, proposer is going to offer exactly the threshold as upper bar. And we know that S upper bar is a positive number. So it's very interesting that proposer with beta less than half. So this proposer is the type of person who doesn't really care about others, doesn't really care about inequality. But this proposer still offers positive amount to responder. So why does he do that? Because proposer is afraid of rejection. So because proposer is afraid of rejection of responder, we can see that proposer is willing to offer some positive amount to responder. So we can see that offering positive amount here is because of strategic reason. So we can see that in this ultimatum game, we can see that in our experimental findings, proposers quite often offer positive amount, but maybe it doesn't really mean that proposers are type of person who care about others, because it is possible that proposers offer positive amount because of strategic reason. So proposer is afraid of rejection from responder. That's why proposer is giving some positive amount. So here, as we can see, using this FS model, we can explain why proposer often offer positive amount to responder. And in particular, we can even explain why sometimes proposer offer exactly half of the resource to responder. So if proposer offers half of the resource to responder, using FS model, we can see that those proposers are the type of people who care about others strongly. So beta parameter is a big number for those types of proposers. But otherwise, if we observe proposers who offer less than half but still some positive amount, these proposers are type of people who don't really care about others, but they still offer positive amount because of strategic reason. And one more comment about this threshold S upper bar. So we know that S upper bar so this number S upper bar, so this number, so this threshold is alpha over 1 plus 2 alpha, and this number is a function of alpha. So we can imagine that if alpha gets bigger, so we can imagine that if alpha so it is a function of alpha, so we can think about what's going to happen to S upper bar if alpha is increasing. So we can take derivative here. So we can take derivative here. So in this case, we're gonna use a rule of derivative differentiation. So rule of differentiation is so if there is a fraction and in the denominator and numerator you have a function and you want to take derivative of this kind of fraction, then the rule is so you square the denominator and take derivative of numerator and multiply denominator minus numerator times derivative of denominator. So this is a rule of differentiation. So we're gonna use this rule. So derivative of numerator, so 1 times denominator minus numerator times derivative of denominator, so it's 2. So we can see that this is a positive number. So this derivative is positive, so it means this threshold is increasing in alpha. So in other words, if alpha is bigger, then the threshold is increasing. So in terms of this graph here, if alpha goes up, then this threshold also increases. So in other words, so threshold is increasing as we can see in this picture. So what does it mean? So alpha gets bigger. So if responder feels greater envy about proposal because of this inequality, then in this case, responder is more likely to reject the offer because if responder accepts the offer, then from this outcome, responder is going to feel great envy. Then responder's utility is going to be negative because of this utility, and responder doesn't like it. Therefore, if alpha is big, so responder is the type of person who feels great envy about inequality, then this type of responder is more likely to reject the offer. So it means, as you can see in this picture, it means we can express this kind of behavior by having higher threshold for rejection. So if S upper bar is bigger number, then as you can see, the rejection area is now expanding. So it is possible, in that case, it is possible that responder may reject offer even when the offer is kind of moderate offer. So for example, let's say here the number is 0.4, so 40% of resource. So it's so if S upper bar is here, it means responder is the type of person who doesn't have that kind of big envy. Then if proposer offers 40% of resource, then he's gonna accept. But if threshold is here, so it means proposer is facing a responder who feels great envy, so alpha parameter is really big. Then in that case, if proposer offers 40% of resource, then it is possible that it is rejected by responder. So proposer can anticipate responder's behavior. So if proposer thinks that he's facing tough responder, so here tough responder means responder is type of person who really cares about inequality. So alpha parameter is really big number. So responder's rejection threshold is really big. Then in that case, because we know that proposer is offering as upper bar, even when he doesn't really care about inequality, this offer can be increasing. So this is why so in our ultimatum game experiment, we oftentimes we let individuals to interact over many rounds. So for example, let's say there are So let's say there are 12 individuals participating in the experiment. Then in the first round, we group first and second individual as one team, and third and fourth individual as one team, and so on. And we let them play ultimatum game. And in the second round, we shuffle them. So now first and third individual becomes a group, and second and fourth individual become one group, and so on. And we let them play ultimatum game again, and so on. And sometimes it is possible that we group them, so first and second, third and fourth, and so on. And we let them play ultimatum game for many rounds with the same group. So in these cases, we let individuals to play ultimatum game experiment for many times. So in this case, but as they interact with each other, maybe in the beginning they don't know whether the other person is what type of person. Does he really care about inequality, or he doesn't really care about inequality? In the beginning, maybe they don't know. But as they play ultimatum game experiment for many rounds, they can get some clue about type of the other person. Then over time, it is possible that they adjust their behavior. So for example, in the beginning, proposer offers a very small amount to responder, but it is rejected. Then now proposer may learn that the other person really cares about inequality. So the other person has high threshold of rejection. Then in that case, next round, the proposer may try to offer more than in the first round, and so on. So gradually, individuals are gonna learn about other individuals' types. So they're gonna adjust their behavior. So eventually they're gonna settle down. Maybe according to the prediction of FS model. So as we saw here, by using FS model, we can explain many facts about experimental findings in ultimatum game. So again, traditional theory couldn't explain our findings, but as we can see here, FS model is quite rich, and it can explain many things about our experimental findings in ultimatum game.